Namaste. Today let's continue the numerical sessions of chapter electricity. In previous class also we discussed so many numerical sessions, and today we will directly go for the questions. The first question is, an electrical iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 2 minutes. The question is very simple. There is one electric iron box, and that iron box, it is having a resistance of 20 ohm, and that is drawing a current of 5 ampere, and for 2 minutes continuously it is working. So you have to calculate how much heat energy is developed. Again, after understanding the question properly, write down the given data. The first concept, resistance 20 ohm is given, and current absorbed is 5 ampere, and you have to calculate heat developed. Heat is a form of energy. That's why you have to calculate heat energy. So it is indicated by the letter E, or you can also use the H also. Okay, and time is given as a 2 minutes. Again, convert all the values in terms of SI unit. SI unit of resistance is ohm, current is ampere, and SI unit of time is seconds. So convert the minute into the seconds. You know already 1 minute is equal to 60 seconds. So 2 minutes means 2 into 60, it means 120 seconds. So now directly go for the formula. We know heat energy can be calculated with the help of the formula E is equal to I square into RT, or you can also write it as W is equal to I square into RT. And all the datas are here, just substitute them. So current is given as a 5 ampere, so 5 square, and resistance is 20, and the time taken is 120. Be careful, don't write it as 2 minutes. Write it as 120 seconds. So by multiplying 25 into 20, it becomes 500 and 120. So finally you will get the answer as 60,000 joules. So 60,000 joules is the amount of heat generated by the iron box. So this is what the solve of the first question. And now let's go for the another one numerical session. And in this numerical session, there is one circuit diagram here, and in this here there is first resistance which is connected in series combination, and two more resistors R1 and R2, R2 and R3, both are connected in parallel combination, and all of them they are connected for the battery which is having a potential difference of 12 volts. In this circuit diagram, you have to calculate, or you have to find the total resistance developed in the circuit and the total current flowing in the circuit, and third thing is just potential difference applied across the first resistance. Okay, so now as usual write down the given data. So first given data is resistance. First resistance value is given 4 ohm, okay, and second resistance value 3 ohm, and third resistance value 6 ohm. Total potential difference is 12 volts. Okay, so now again let's solve the question. First thing is, you have to calculate total resistance developed in the circuit. Observe the diagram properly. First resistance is given in series combination, and second resistor, third resistor, both are connected in parallel combination. We know already, if the circuit is in parallel combination, you have to use the formula Rp is equal to R2 R3 divided by R2 plus R3. This is the standardized formula to calculate the total resistance in parallel combination, or you can also use 1 by Rp is equal to 1 by R1 plus 1 by R2, that is also right. But here instead of R1 and R2, we have taken R2 and R3. Okay, so now first resistor is in series combination, so R1 I will write it directly plus series combination, Rs is equal to R1 plus R2, that is the formula for series resistance. And again you have to calculate the total resistance created in the parallel combination. Directly I will write the formula R2 R3 divided by R2 plus R3. Simply just calculate, substitute the values. R1 value is 4 ohm, R2 value is 3 ohm, R3 value is 6 ohm divided by 3 plus 6. 6 3s are 18, 6 plus 3 9, 9 1s are 9 2s are 4 plus 2, that means directly we will get it as 6 ohm. So total resistance created in this circuit is 6 ohm. This is the first solution for this circuit. Second question is, calculate the total current flowing in the circuit. To determine the total amount of current flowing in the circuit, we know already current formula, that is I is equal to V divided by R. And one more formula is there, I is equal to Q by T. But here the given data is potential difference and resistance. So use this formula only, that is V is equal to IR formula. By just interchanging, you will get it as I is equal to V by R. So directly substitute the value, potential difference is 12 volts or electric potential is 12 volts, and total resistance we have calculated here, that is 6 ohm, 6 ones are 6 twos are, directly will get it as 2 ampere. So 2 ampere is the total amount of current flowing through this circuit. And always remember, if the connections are given in parallel combination, then potential difference is same. And if the connection is given in series combination, if the resistors they are connected in the series combination, then the potential difference is different. Remember this fact. So third question is here, calculate the total potential difference across R1 only through the first resistance. How much amount of potential difference is creating, that thing you have to calculate. So potential difference across the R1 is given by the formula V1 is equal to I into R1. Okay, V1 is the potential difference applied across the first resistance only. Already I told you, in series combination potential difference is different. So that's why we will write it as V1, which is equal to I into R1. I is the current and R1 is the resistance. Don't write it as I1 because current is same here. So that's why I into R1. So current created is 2 ampere and first resistance value is 4 ohm. So 4 into 2 means you will get it as 8 volts. This is the potential difference applied across the first resistance. If they ask you the question, determine the potential difference applied across the R2 and R3, then what you have to do is subtract this 12 as well as 8 volts. How much you will get? 12 minus 8 means 4 volts. 4 volt is same for both the resistors. 4 volts is the potential difference applied for the second resistor and 4 volts is the potential difference applied across the third resistor also. So these are the 3 important questions which can be asked in your electricity chapter for your numerical sessions. Okay, do it perfectly and remember, try to remember all the formulas. Okay, thank you.